all the presenters, viewers, and members of IBA. My name is Siddharth Desai, and I'll be moderating this session on contemporary technologies. We once again thank IBA team and the organizers for arranging this informative two-day event. We had a wonderful conference yesterday and today, and as is evident, there is no better time to be a part of this bioenergy community. Over the years, we have seen consistent and growing acknowledgements from governments the world over on the importance of bioenergy and its role in the energy mix. Everyone is aware that bioenergy potentially achieves three critical policy goals the world over, that is reduction in waste management practices, addressing climate change, and providing energy security. We often speak about the three R's in sustainability, that is reduce, use, recycle. With bioenergy, what bioenergy does is it allows us to have a fourth R added to the mix, that is the fourth R is recover. So now we need to redefine processes and operations with the motto of reduce, reuse, recycle, and recover. Now, in India, like in many other countries around the world, the government at all levels is incentivizing more use of bioenergy for commercial purposes. They're having big ticket policy initiatives like the Satat, everyone is aware of that, and also micro-level capital support schemes at state level for development of bioenergy projects. To supplement this market-enabling mechanisms initiated by the governments, what is lacking is there is a huge potential to improvise, to innovate, and build on existing experiences and technologies to enhance the output of biofuels, which will lead to higher contribution in the overall energy mix. Innovators and entrepreneurs across the world are seeking new, in the literal sense, new pastures for improving the efficacy of processes used in bioenvironment. So today, we have 5 such innovators and entrepreneurs who will provide insights into the available technologies related to various aspects of bioenergy, which will enhance the economic viability and increase the production of and use of bioenergy. So we'll be hearing from these 5 distinguished presenters. First from Mr. Mathiel from German Biogas Association, then from Mr. C.R. Baswaraj from Praj, Mr. Ashish Maheshwari from Evonik will present the next, followed by Dr. Jing Lui from BPC Instruments, and finally Mr. Lavraj Khamkar from Time Technoplast. Each presenter will have roughly 20 minutes to present and we questions from the viewers at the end of the session. So with that, I'll first like to introduce to you Mr. Matthias Hartel. Can you switch on your video, Mr. Hartel, please?
Yes. Hello, everybody.
Great.
Can you hear me? Yes.
Yes. So I'll introduce Mr. Hartel quickly. So he is a student of architecture and has been dealing with topics of energetic bus use and material flows in the landscape for several years. He had been working in waste management sector before to the applied research, where he carried out various projects to optimize biogas process. In 2019, Mr. Hartel started working for German Biogas Association in the departments of waste, fertilization and hygiene, and member services. He is involved in the work of national and European legislation, primarily in the areas of waste, fertilizer, and veterinary law, through participation in various working groups, the preparation of statements, and direct discussions with representations from the relevant ministries. So, Mr. Hartel, it's an honor to have you with us today. So, please, you can start your presentation. Thank you.
Thank you very much for the nice introduction. Welcome from my side to all participants. I hope you see my presentation. A short feedback? Yes, okay, fine. Thank you very much. I will highlight in the next minute some aspects about application, upgrading, and marketing by using digestate as fertilizer. You'll see that we have a publication on our homepage, digestate as fertilizer, so you can get more information about the theme here, and it is for free to download. So first of all, this presentation will take place in the connection with the German Biogas Association and the Indian Biogas Association for the improvement of the institutional framework and the use of biogas in India until November 2021. And it is financed by the German Federal Ministry of Economic Cooperation and Development and managed by SIGWA. First of all, I want to show you to see the chance of digestate as fertilizer, as organic fertilizer. In Germany, we have 82 million tons digestate per year in Germany. And when we look to the nutrient content in the digestate and compare it to the share of nutrients in the German market of anorganic fertilizer, we see the potential of the substitution of anorganic fertilizers with 11% for nitrogen, 56% for phosphate, and 76% for potassium oxide. So the substitution of anorganic fertilizer has also other aspects, because we have a high energy demand to produce nitrogen for the mineral fertilizer production, and phosphorus and potassium and peat are finite resources, and they have a wide transport path. Another aspect is the phosphorus will be extracted by mining, so we see an increase in cadmium and uran content in the mineral fertilizer. But when we look to the price to the development of the price of the pure nutrients in the mineral fertilizer the last years, quite apart from the peak here in the middle, 2008, with this caused by the economic crisis, we see an increase in price for the pure nutrients. So this can be a chance. And when we go to the application of digestate, so it's a circular economy to use digestate as fertilizer. In the agriculture sector, we depending on the demand of the plants and the growth of the biomass, we can applicate the nutrients to the biomass, and on the end we can use it in the biogas process to generate biogas, electricity, heat, and fuel. And after the fermentation, we have a highly valuable nutrient and humus-rich fertilizer, which we can apply to the field. For the application, we have several technologies available. Most common is the wide distribution, but because of the reduction of emissions to the air, it's much more better and to put the nutrients close to the soil. This can be done by the drag hose, or we can inject the nutrients directly into the soil near to the roots. So by the technology drag or slid shoe or slurry cultivator, and for the solid fraction, we can use universal manure spreader. But another aspect is the low content of the nutrients, depending on the dry matter content. That means for distance up to 5 kilometers, this can be profitable. After that, we have to think about spreading with separate mechanization. The second part and thinking is upgrading technology. This is also possible inside of the agriculture nutrient circle, but it is also possible to decouple to fractional single nutrients outside of the agriculture, and for the utilization in the industry or also in the agriculture, for example, phosphate salt. So therefore, we have several processing possibilities. So the first step is always the solid liquid separation. After we have several other processings like thickening, evaporation, drying, total upgrading. Here we see the main reasons for upgrading fertilizer, reducing cost for storage, transport, application, because we have seasonal restricted application, nutritional requirements of the plant, the storage capacity during the winter. We want to reduce the water content and increase the nutrient content, but therefore to establish new markets is necessary. Outside of the agriculture, we have to establish new markets, so replacing growing media, one point, or potting soil, peat substitution, etc. Marketing in gardening centers is also a point. We have the possibility to use it for landscaping, viticulture, and also relief of nutrient circle in case of land use pressure can be a reason for upgrading fertilizer technology. And another aspect is the production of fertilizer, which is demand oriented to the customer. So we can adjust nutrient content. Another aspect is also reducing losses of nutrient, nitrate losses, emissions, animal welfare, and the improvement of the appearance and handling is also an aspect. Here we see a short overview about digestate upgrading technology. You can find it also in our publication. On the left side, we see several input substrate, animal byproducts to energy crops. Then we have different technology we can use. So depending on the dry matter, for example, we have wet continuous digestion to dry bed AD systems. And the first step will be the separation in the liquid and solid fraction. For these single fractions, it is also possible to apply them directly to the field. This is the first step of upgrading technology, which is necessary for the further on technology. For the liquid fraction, we have different vacuum evaporation, membrane filtration, precipitation, or stripping. And in case of to fulfill the requirements on injection in water bodies from the clear water, maybe we need a wastewater treatment. For the solid fraction, we have also composting, drying, and pelletizing. And on the end, we have different products, so N-reduced digestates, ammonium sulfide solutions, or P-reduced digestates, or here for the solid fractions, pellets, pieces, or granulates. Here we see a nutrient content of separate digestate, the first step, so liquid fraction and the solid fraction. And we see that after this part, we have two different fertilizer. So the fibers and the humus-rich things are more in the solid fraction. We see it here. And the ammonia, which is available for the plant or forced available, it's more in the liquid fraction. In Germany, we have to do some analysis, several analyses. So to fulfill the legal requirements, they must be controlled, and it is the possibility for the operators to take part on an independent quality assurance system. So the requirements will be controlled by a certification organization, and during the process of quality assurance during 1 year, we have the result on the end that we have a receipt of the specification mark, which can be labeled on the product. Let's have a look, a short look to the marketing, actual marketing. We see here compost. There were made some efforts in the past. So we have several other sectors outside of the agriculture system. So landscaping, hobby gardening, marketing, and specialized agriculture. For the liquid digestate marketing, we see mainly the market is in the agriculture, but we see here also in the ecological part of the agriculture a market. And for the solid digestate, we see also mainly the agriculture sector, but also landscaping, other and ecological agriculture. In Germany, we had also a research project for like a study with interviews to decision-making behavior of private gardeners. So what is necessary, what they expect from the product when they want to have a product to fertilize their plants. And the results of the interviews is that we see in general high uncertainty of the customer, often to less information about products, no research. So he consults the retailer, but with low satisfaction. And on the end, he decides with the product name on the packaging. So that means when he wants to buy a rose fertilizer, he will buy a product where it's signed with rose fertilizer. Other differentiations between ornamental and edible plants are also visible. Look and feel, what I mentioned before, is important for assessing the application, and amazing importance of traditional rules of thumbs. So like my grandma did, fertilizing with coffee grounds, so I will do this also. Here we see the product attributes. So on the left side, the product name, the brand name, label, and the difference on the attribute level between an all-round soil and a potting soil, and several brand names, labels, resources, and pieces. And the result we see here, the willingness according to the different product groups compared to the all-round soil, we see for the potting soil a willingness to pay more of about nearly 40 cents. And these effects we see on other specifications, but it is not possible to took more than one specification on one product, so we have no cumulative effects. Another differentiation is the willingness according different customer classes. We see here resource sensitive premium customers or price sensitive customers. And also here we see, depending on the level, different willingnesses to pay more for the product. Some words to the strategy of marketing. It is possible to bring out the own product. So each biogas plant has its own brand mark and product and his own customer. A second strategy is franchising. So several biogas plants have a common brand name and different customers on the end. And a third strategy can be different biogas plants are delivering the raw material to the central fertilizer factory, and we can add nutrients, aggregates, demand orientated to the customer. So at this point, I come to the conclusion. So digestate is an important product of AD, which can be used as valuable fertilizer. So liquid manure as input substrates, ecological and economical beneficial because of the emission reduction. The interest for upgrading technology is increasing, so that we have to look also to the legal compliance and economic optimization aspects, and also the aspect of reduction of mineral fertilizer by closing material cycles. So the technology itself depends on the location and the size of the plant, because we have to look if we have a heat demand on the background. And for the marketing, the market has to be established. So we have different scenarios possible: raw material supplier, individual product marketing, and in this context, also certification can increase the acceptance of the product on the end. And to the product attributes, it should be customer demanded. So we need products which the customer wants to buy. At this time, thank you for your attention, and I hope we see us not only virtual in December on the Biogas Convention and Trade Fair in Germany. Thank you very much.
Yes, thank you, Mr. Hartel. It's been a very informative session, hearing from you about digestate as a fertilizer, and in the perspective that India recently announced a digestate policy. This is very informative for all the members of this community. One very important point you mentioned was about the willingness of customers to buy. And I think this is a problem or issue across the world and needs to be addressed apart from technology and policy. So thank you again for your presentation. With that, I'll introduce to you Mr. Basuraj. So Mr. Basuraj is master's in environmental engineering, having 20 years experience in the areas of organic waste to biogas, water and wastewater treatment projects in process industries like distilleries, breweries, dairy, starch, paper mills, MSW, pharma, fertilizer, and other chemical industries. Working in the area of alternative biofuels like biogas to CBG for vehicular and industrial application, biogas to power, waste to biogas, biogas scrubbing, that is H2S scrubbing systems for biopower, CO2 systems. And he has been working in RenGas business of Praj Industries Limited. So with that, Mr. Basaraj, you can start your presentation.
Yes, sir. Thank you. Am I audible? Yeah.
Yes, very much. Yes, it's visible. The screen is visible. Thank you.
Yeah, so my screen is visible. Yeah. Thank you. One moment. So good afternoon, everyone. Thanks to IBA for this opportunity to present our perspective for the CBG projects. So today I'll be talking on Praj's value proposition for CBG projects. So in the content, I'll just a couple of slides on corporate information, and then I'll take you through the Praj's technology and the value proposition. So, so I would like to share our recent achievement. So as you know, the Biofuel Digest, which is the highly read, world's most widely read biofuel magazine. So they have rated Praj as a best workplace to work in biofuel or bioeconomy segment. We have been as the second position for this renewable fuels and biomaterials. And similarly, when it comes to this biodesign engineering organization. So this is what are recent achievements. And as you know, the Praj is almost more than 35 years old company. So with more than 750 references for the distillery business or in the biofuel business, which is a liquid biofuel. And so we are almost 1,200 employees working, and we have been supported by our R&D center called Matrix. And globally, the ethanol production contributes, or the generation from our plant is about 8%. And so this is the fact at a glance. And our business offerings is BioEnergy is one of the business vertical, and we have our R&D center where the major focus is on liquid biofuels and gaseous biofuels and biochemicals. And in the engineering businesses, we have a brewery division, we have critical process equipment, and the environmental division, which is for effluent recycle and jetted solutions. And we have one more vertical in a high purity segment, which is called Praj High Purity System. So as I was mentioning, that the entire technology or the innovation, whatever comes up and which is supported by our Matrix R&D Center, which is certified by DSIR. And so we have more than 90 technologists and more than 25 doctorates working in the R&D center. So just to give you an idea, the concept level working, and right from the bench to pilot scale facility we have for all the biofuel pilot projects which we can take up. And then the Praj's biomobility platform, wherein we contributes to bioethanol generating from 1G and the bioethanol generating from the cellulosic feedstock. So we have a biodiesel, biomethane, and marine biofuels, so a sustainable aviation fuel. So all these are the platforms of biomobility where Praj is working. And out of that, CBG is one of the platform or one of the business vertical where we work. So this entering to the today's topic of Praj's perspective or the understanding of the CBG business. So we deal with the feedstocks from sugar factory waste and biomass based. And so these are the feedstocks which we are catering right now, the agri residues, and also the sugar factory feedstock, maybe press mud, spent wash based feedstock. So these are our focused attention at this time. And the technology pieces, where we are contributing or where we are bringing the differentiation is in the pre-treatment section, followed by the dual flow reactor, which is a biomethanation process. So followed by the gas purification system and the organic manure. Just now my fellow presenter has very nicely elaborated how the liquid manure can be utilized and what are the present practices in Germany. So which is one of the burning issue today in India for the CBG business. So wherein we are also contributing in this to make this liquid manure under NOCA certification. For this liquid manure also will help our customers to get it done. So as I said, the pre-treatment of any raw material, particularly when we talk about sugar factory press mud, is very important. As you understand that the sugar factory or the season is for 150, 160 days in India, but we need this CBG plant to operate throughout the year, maybe 350 days or 330 days in that region, in that range. So it is very important to preserve it. Otherwise, it will get degraded or it gets deteriorated. So with that, we have came up with a unique patented technology, which is our PM stab. And then when it comes to similarly, the pre-treatment technology is very important for the biomass feedstocks. So wherein so we are also doing BM sol microbial pre-treatment, and then we are subjecting it to biomethanation process. So so once the pre-treatment is done, so going to second stage with the production, actual production of biogas is also very important. So we are with our technology partner from US, DVO Inc. We are working with them, and this gives an advantage. Here we can work in a biphasic manner, which gives a better degradation of volatile solids present in any of the feedstocks. So these are the USPs. The solid retention time is more, SRT is more, HRT will be less. So these are the advantages which are helping the flow reactors to give better efficiency. And then followed by that, once the gas is generated, if you understand the 3 to 4 segments which are the very critical, is you should have a proper feed material, and then you should have a proper production unit, and then once the gas is produced, you should purify it to bring to IS specifications, IS 16087. So that is also critically important. So wherein we have the in-house technologies and also the collaborative technology with our technology partners. So we have a catalytic based H2S scrubbing process, followed by CO2 removal. We have an option of membrane based and chilled water based on the requirement to achieve the IS grade. So because it is also very important, if we if we achieve to this specification, then only it is compatible to use it in the vehiculars. So gas purification is also one of the critical unit operation in the CBG project. And the fourth one is once the digestate or the digested slurry comes out, is to be separated in two forms, one in liquid form and another one is in a solid form, where it has where we call it as a co-product from the CBG project, and which will also contributes about 25 to 30% of the revenue in the CBG project. So manure generation, fortification, and selling of the manure is also equally important. Then we have our own demo plant for different feedstocks to operate. Where before we take any of the technology to the commercial level, we do proof of concepts, we do pilot plants, and then only we take it to commercial level. So these are a few of the projects which we are executing in north part of India with India Potash Limited, and one project in Karnataka, Lifinity. So where we are in the stage, in one of the project we are in the stage where we will very soon start the commissioning of this project, and another one is at the construction stage, which will take a couple of months to come to the construction. So once the gas is generated, so you need to compress it, fill it in the caskets, and then it will be sold it through oil companies under Satat program. So this is how the entire biomobility CBG contributing as a biomobility fuel. So this is about the technology, and now I would like what do we feel? There are certain interventions required from the IBA and all from the stakeholders to work with the governments to take these projects, take the CBG to the next level. So under Satat program, we feel that 100% offtake of CBG produced to be assured, and then directives for CBG injection in this CBD network should be given clearance. And this MNRE benefit, I think yesterday MNRE representatives are also spoke about their perspective of perspective on CBG projects. So the price of CBG, as you see, the price of petrol in recent month, it has reached almost 100 rupees, at least in Pune. So in a way, the CBG price should also be linked to the petrol prices, also some sort of linking should be done, and FCO notification for, I think it is almost through for liquid manure, but it is yet to come in the gazette notification. That's what is my understanding. So there should be some floor price fixing for the agri residues for next 5 years. So then the investors feel a little bit confident to go for these projects, because the assured raw material with an assured or the fixed pricing of raw material is very important. Otherwise, the project's investor will feel little uncomfortable in going with this project. So these are the certain interventions required from IBA side and other stakeholders to take this forward. So one of the things is like carbon intensity program in rest of the world, which is very popular or now very seriously linked into it. But I think this practice has to start in India. So we feel that we are also along with IBA we would like to take this with the government. So with this, I would like to conclude my presentation. So thank you, Siddharthji.
Thank you, Mr. Vasuraj. It was great to hear about Praj's value position and also the development of the plug filter, which I recollect that even in the lockdown, your team worked very hard to commission the pilot project, which was inaugurated online using a Zoom platform again. So thank you very much for the information and the presentation. Next, I'd like to invite Mr. Ashish Maheshwari from Evonik. Mr. Ashish Maheshwari, can you switch on your camera?
Yeah, hello.
Hello. I'll just quickly introduce Mr. Ashish here. So Mr. Ashish is a chemical engineer from Nagpur University and holds a master's in international business. He's having more than 20 years experience in various polymers and experience in various areas such as manufacturing, project handling, and sales. Currently representing Evonik, he is responsible for marketing and sales of high-performance fibers and specialty polymers. His major activities are business development and technical support related to Sepuron, the hollow fiber membranes for efficient and energy-saving gas separation. Sepuron stands for the pure and efficient separation of gases for biogas upgrading and the separation of nitrogen from air or for removal dioxide. Hydrogen generation or helium recovery is also part of the range. He's particularly supporting Evonik's part use Sepuron Green, which is a membrane dedicated for biogas upgrading and use bio-natural gas from biogas generated from different feedstocks. So with that, Ashish, you can start your presentation. Thank you.
Hello, can you see my screen?
Yes.
Okay, thank you. Thank you, IBA, for giving opportunity for us to present the technology, especially for biogas purification by efficient membrane technology. Evonik is a creative industrial group from Germany and acting into the specialty chemical company. Evonik operates worldwide and have global presence, including USA, Europe, Asia, China, India, and Middle East. In India, we have the head office in Mumbai and regional offices in South, North, and Western part. This is the plant of Evonik Fiber, where we manufacture fibers and hollow fiber membranes that is located in Austria. At high performance polymer product, we manufacture polyamide for automotive application, polyimides for hot gas filtration, hollow fiber membranes for gas separation application. Apart from that, we manufacture polyether ether ketone peak for industrial application and medical application. At Evonik, impacts on full value chain leads to the superior membrane product. Here we manufacture starting from our monomer product range to polymer, and then it has been converted to hollow fiber and ultimately to membrane cartridge. Although we don't manufacture the membrane system, plant system, but we integrate with our OEM in terms of technology knowledge and application development. So this entire value chain impacts the better quality of the product and the better permeability. This is the gas separation process using a hollow fiber membrane. At the center of this, you can see the different bundle of hollow fiber that has been entangled into the membrane cartridge. In the bottom, you can have look at the permeation rate of various gases. The methane, argon, nitrogen, they are the slow moving gases, whereas in case of carbon dioxide, moisture, they are the fast moving gases. When we feed this gas, biogas feed, to this hollow fiber membrane, then we get methane enriched retentate. And another product stream is CO2. CO2 will become on the permeate side. This is the principle of membrane operation. Coming to Sepuron product family, at Evonik, we manufacture various membrane products, including Sepuron Green, that goes for the biogas purification. We will go in detail in coming slide for that. It is a market, we have the market leading position in the biogas application. Apart from that, we cater to Sepuron Noble for hydrogen recovery, helium recovery, H2CO ratio adjustment in syngas, Sepuron N2 for nitrogen generation, superior air factor we have in case of nitrogen, and Sepuron NG for natural gas application. There are some prejudices about the membrane technology, like membrane technology has a limited lifetime, but from our experience, we see that our membranes can perform around 10 years. That is the general thing we have found. We will go in details in coming slide. Second, the membranes are sensitive and risk of damage. This is also one of the important factors we have to take into consideration. Pre-treatment is needed before the gas goes to the membrane. This is not only because of the membrane This is for the entire value chain. Next thing is that it can come for the small scale application. This is not the truth. Our membrane-based plants are operating, say for example, 6,500 nm³ per hour or 4,000 nm³ per hour. And we have more than 50 projects which are running greater than 1,000 nm³ per hour biogas. Next thing is that it has expensive, but we can say membrane is the most efficient technology in terms of pricing, capex and opex. These are the most reliable and flexible systems. Coming to pre-treatment part, this pre-treatment is very important, and if you can see, there are various block diagram which shows the different types of filter incorporated during the processing before the biogas comes to the membrane. These filters are activated carbon filter or dehumidifier, chiller, dryer. This process we have to take in a consideration and manage it so that we can get the proper purity and selectivity of the methane. The contaminants and Sepuran green. Sepuran membranes are basically based on the polyimide polymer. And Wikipedia also says that polyimides have the excellent mechanical property, good chemical resistance, known for thermal stability, and typical PI are not affected, commonly used solvent and oil. So sometimes we see the loss of performance due to contamination, and that can be mostly explained as a physical phenomena. There is no chemical structure damage or changes happens, and this loss of performance due to physical phenomena can be brought back by flushing the biogas, pure biogas, and we will get the same purity and recovery with the membrane. Refer to H2S and water moisture level. Polyimides are well known for their very resistance against hydrolysis. Water vapor is not reactive enough to undergo any reaction with polyimide polymer, and H2S is even less reactive than moisture. Therefore, it cannot react with the polyimide and it cannot degrade. Second, about this expensive things which we will highlight in detail. We support the entire support for the Sepuran green stage process in 3-stage process. Our product is, we have the IP protection for 3-stage membrane with 1 compressor, and this will help us to significant reduction in operation cost. And when we will compare this capex and opex part, then this is the best suit for this technology. This is exclusively available to our OEM partner. This is the software which we provide to our OEM, and based on that, they will design the entire sizing, how many membranes will be required, and we will get the gas composition at various levels, including feed, intermediate, product, permeate stage, retented stage, along with temperature and pressure. So you can see these are the different types of plant with more than 400 references worldwide. We will see some of the major references. So this is the example of our first reference plant at BioEnergy in UK. So this is the oldest plant which has started in 2011, and it is still in operation without any loss of performance. The plant capacity, biogas capacity is 650 nm³ per. And the final application is grid. So you can see this plant. Another important example is Yesco Sol plant. This is for gas grid application, injection, private household application. Biogas has been generated from sewage sludge wastewater treatment plant with 1500 nm³ per of the biogas, and this is operating at 10 bar with 3-stage membrane process. This is the plant at Mine project in China, and this has been built by our OEM partner Envitech. They have designed this plant. These are the two lines of 1000 nm³ per hour biogas with 97% purity, and the application is for compressed biogas CBG application. This is a project in Italy, Europe, Montello. Here we can see there are 5 lines of 1200 nm³ per nm³ per hour of the biogas, and this has been generated from this MSW, municipal solid waste, with purity more than 97%, and the application including CNG and gas grid. So process can be designed 2-stage, 3-stage based on the need and the recovery required. So this is the recent development plant built by Indian OEM partner for the Nepal. It's a small plant with 175 nm³ and purity more than 95%, and application is in cooking gas. So we can handle different types of the substrate for the biogas, including agricultural, energy crops, chicken manure, feed, different. And we can get these analysis like carbon dioxide, methane, and that can be get into different purity where we can make for the different application. Either CO2 is needed for industrial grade or food grade, that can also be captured with the membrane technology. Sepuran green technology basically offers various advantages, and one of the major advantages is that biomethane, the CBG, is at a system pressure, that is at say 12 bar, 16 bar, whatever we design, that is at the 16 bar. It's in dry condition and in pipeline spec. The plants are easy to operate, start and stop. These are basically modular, so you can increase the capacity. There is no maintenance for the membrane part. You can easily get back the membrane performance within short duration, and this will help you the high availability of the plant. This is the green technology. There is no use of chemical, no water, wastewater has been used. In terms of price, it is the best optimum for the CapEx and OpEx. When we consider electricity consumption and all operating costs, then this is the best price comparison for CapEx OpEx. So coming to the entire video about the technology, we can see this. So these are basically hollow fiber membranes for efficient biogas purification. This is the membrane cartridge available into different size, 4-inch, 6-inch. And we have designed a new generation of fibers also, which are highly efficient. These are the fittings put together. So this you can see the bore side, the feed has been entering into this hollow fiber. And we are getting 2 streams, one retentate and another is permeate. When we look at this different types of the gases, those are entering to this hollow fiber, like CO2, methane, water vapor, H2S, then we can find that methane is retained and CO2 will pass. These are the different stage processes, one single stage, 2-stage, 3-stage with single compressor, electricity consumption less than 2, recycle rate also very low, less than 60%, and highly selective membrane, which is having the selectivity ratio of greater than 550. These are simple, modular. You can incorporate the membrane number, cartridges, and increase the capacity of plant once the feed has been available. So this will play the investor a good amount of flexibility. And our OEM can make it as a modular in a containerized system. And this is the plant entirely, it takes a very small space also. So thank you. I hope this is the entire things about the membrane technology. Thank you for your attention.
Thank you, Mr. Maheshwari, for the nice presentation, and it's great to learn about Evonik's innovation in materials, especially polymer membranes, and also the innovative, efficient process design to make the overall system OpEx and CapEx competitive. Thank you so much.
Thank you.
next, I'd like to introduce Dr. Jing Liu from BPC Instruments. Yes, I'll just introduce him. So, Dr. Jing Liu is an inventor and co-founder of Process. It is renamed as BPC Instruments in the second half of 2020. Earlier, he has served as Chief Technical Officer and Board Director since the company was established in 2005. Since 2013, Dr. has been fully responsible for the operations at Bioprocess Control. He was formally appointed as CEO to lead the company into an exciting growth phase. Is also an associate professor in the field of environmental biotechnology and bioenergy at Division of Biotechnology in Lund University in Sweden. He has over the past 20 years, his work has been focused on both technology and business development in optimization of the anaerobic digestion processes and environmental analysis, with special emphasis on research development and industrial applications of instrumentation. Dr. Jing has been nominated for several research and enterprise awards in Sweden. He has worked as a senior scientist in anaerobic digestion and environmental specialist, leading both academic research projects and industrial product development projects since 2004. In addition to having a strong technical and engineering background, he has over 20 years work experience with technical and business development in the pharmaceutical, environmental energy and biogas industries, including over 15 years of experience in strategy development. So with that, Dr. Liu, I'd like you to present your presentation. Thank you so much.
Thank you, Mr. Chairman, for your introduction. It's my honor to participate in this event. And my presentation will be more focused on the methodology for evaluating the biomass energy content, and also the feedstock optimization for biogas production. So I hope you all can see my screen, right?
Yes, yes.
Okay, good, super. So move on. Yeah, as we know that we're dealing with, in the sector of biogas or anaerobic digestion, actually the feedstock is one of the key important factors. We're dealing with organic waste, the biomass. In many cases, we see that as a problem, as we also do in anywhere part of the world, including India. And that has been a problem, the waste, the biomass. But at the same time, it is really can be a good resources. And but some basic fact that we need to keep in mind: organic waste never ever constant in quality and quantity. They're changing all the time. And also it's not only involved in the environmental issue, but also the climate and other issues is heavily associated. And also nutrient recycle, where we have a presenter talking about the fertilizers, everything. So we're looking at circular economy, everything, nutrients, energy, and also need to be recycled or recycled. If we are not
Dr. Liu, I'm sorry, it seems your screen is visible, but the screen you are referring to is not maximized. The following slide is also visible as a small window on the right. Can you maximize your screen if possible?
Oh, so which one you have see? You see the smaller window.
I see we see both the windows, but the one you are, yes. Now, if you maximize, is it going into the presentation mode?
I'm trying to do that. It's better now?
It's the same thing, but I think it's visible. That's fine. If it's
let me.
You can continue. I think it's okay. It's okay.
Let me try to. Sometimes it's.
This is better. This is better. Yeah.
Sometimes it's like that. Is it better now?
Yes, it's better. Thank you.
Okay. Let's get back to the point. So, but yeah, as we said, the basic fact, and but also there for organic waste and the biomass, there are various ways solution to treat those: aerobic, anaerobic, landfill, composting, incineration. There are more, but among those, anaerobic digestion or biogas production is one of, I would say, the most realistic and most environmental friendly solutions for organic waste and biomass. And as we know also, it's producing the renewable energy in form of biogas or biomethane. But I would say, as I mentioned, the quality of organic biomass and organic waste never constant in quality and quantity, but also the biodegradability and the energy content of organic waste vary significantly. So it is critical that we need to have a knowledge on the organic waste and biomass characteristic, because they have a huge impact on the treatment process and the economic of the plant. I would say the most of uprunning biogas plant, the practical problem that they are counting, I would say 80–90% indirectly or directly associated with the feedstock. Either it's not appropriate feedstock for the plant that was original design, or they are lacking of feedstock, or they are putting the wrong feedstock that the bacteria cannot handle, and so on. So it is critical to have a much better understanding of the organic waste, biomass quality, and also their degradation profile and so on. And it is important, as I mentioned, for process optimization, for feedstock optimization, and also to make sure that your plant can be operated economically and have a benefit. So clearly there is an increasing demand for analysis. But actually the reality is still most of biogas plant, the people, when we receive the feedstock, we just put the load to the biogas reactors without knowing what we are dealing with. This is actually a huge issue and can have a really a big risk for the operations. There are methodology, evaluation method to evaluate the energy content and also to evaluate the characteristic of the feedstock, energy content and biodegradability, and such as the biomethane potential, biogas potential, anaerobic biodegradability. The most, I would say, the relevant one is the German VDI 4630. In the version, the latest version is 2016. And also in the recent years, the Italian standards. And there are other standards are similar or relevant, but I would say the most actually related to the biogas production is those two standards. As we know also, when we're dealing with the organic waste or biomass, we also have to keep in mind the greenhouse gas emission. Therefore, there's also a method called to evaluate the residue gas potential to dealing with the greenhouse gas effect, the emission after the digestions. And there are methodology defined also in the VDI 4630. Certainly, there are also aerobic compostability method, but that's not our focus for these presentations. If we look at the evaluation method, the most common one that actually utilized is so-called the anaerobic batch fermentation test, anaerobic fermentation test in the batch procedure. These are actually this kind of batch test is used to investigate the biomass characteristic and the metabolic activity of the bacteria. So it's depending which one you want to analysis. You can analyze the degradability of or energy content from a given biomass when you ensure a good quality inoculum to bacteria. Or you can turn another way around. You're using a standard feedstock or substrate that to evaluate how the bacterial activity in your biogas plant. Both are important. You need to know the feedstock quality. You also need to make sure all these bacterial anaerobics, those bats are working properly. There is a good ecosystem in your digester. So they are basically provide good fundamental information on the biomass, biomethane yield, and anaerobic biodegradability of the feedstock. It also gives the kinetics profile of degradation, which is super important. You may have the two different feedstock giving exactly the same energy content, but the degradation rate are different. That will give you a huge impact on your operation and how you handle your plant. You have a feedstock, you may imagine the impact to your operation will be quite different. So if you're looking at, so this is actually the methodology that commonly used in the both academic world, but also in industry, analyze your feedstock quality. Application of this kind of batch test procedure are BMP, like biomethane potential test, biogas potential test, specific metanogens activity, SMA test, and the residue gas potential. Even also a substrate inhibition test, because sometimes bacteria are not able to handle certain substrate, and it may be need to evaluate the inhibition effect. And we're talking about this topic, we're talking about the pre-treatment. In the market, in Europe, in a lot of countries, they offer different, or company offer different pre-treatment. And there's also, because often when you're dealing with biogas production, you are actually receiving different biomass stream. Then it comes into, okay, what kind of, shall we go for cold digestion and so on. There's also talking about if we're using biomass only alone, like from the agriculture sector, you may need to add additives as a trace element to boost the production. But the thing is, no treatment method, pre-treatment, co-addition solution, co-addition solution and additive can work for any feedstock. You have to evaluate which one fit your case the best, and whether it's worth to apply the certain treatment or co-addition or additives. And this, how to evaluate, using the batch fermentation test procedure to evaluate. It is also super important, as I mentioned, a lot of failure or problem of biogas plant associated with the feedstock related issues. So it is critically important to do the feasibility study on quality and accessibility of feedstock for biogas project. How to do that? Of course, from others, you need to do the analysis. You cannot just look at the textbook or some features, because the feedstock are different from each individual region, from different region, and your accessibility will be different all year round. Yeah. Okay, when we talk about batch tests, we also come together with, we have a continued procedure, but that's not going to be the focus from this presentation. Continued procedure, fermentation test procedure, is more for investigate the process operational condition to achieve the optimal degradation and gas yield. It is also important, but in terms of feedstock quality, evaluation, co-digestion, pre-treatment technology, we need to go for the batch fermentation test procedures. Yeah, here is some apparatus, because the tests need to be carried out in the laboratory. You can be done in the good condition, like in the research facility, or you can should be done in the factory as well. You can have a small test room, carry out these tests as a routine test. The batch test procedure, often there are different apparatus, but basically they follow two types of principles, either monometric measurement or volumetric measurement. Monometric measurement is based on calculating the biogas, biomethane production by a pressure increase in a closed vessel, because when you do the anaerobic digestion biogas production, methane and the carbon dioxide will be produced. If it is in a closed vessel, the pressure will increase. So through the ideal gas law, you can calculate how much methane and carbon or biogas is produced. You can also, through the volumetric method, by directly measure the biogas volume or biomethane volumes. If you look at, so both methods can be acceptable. And if you look at in the early days, monometric based on the pressure measurement is more common, but in recent years, over the past 10 years, actually volumetric measurement is more dominant, and I would say more accurate, because they give the impact on the pressure for gas solubility is much less. There are certain advantages for that.
Dr. Liu, we have 2 more minutes for your.
Okay, so here is some example of the monometric method. These are the classical conventional method, and also there are many impacts for the anaerobic batch fermentation test. There are protocol-related factors, there are biological-related factors, there are measurement-related and data interpretation-related factors. All this, what I want to say is the tests need to be standardized, otherwise you cannot compare. And this also has been an issue. So we're looking for solutions that so there's a technology challenge for batch fermentation test. Too much freedom for interpretation, because the method, it doesn't really specify so we have a problem to compare the data different laboratory. And there's a lacking of the standardization, time-consuming, labor-intensive, and also risk of error due to the involvement of the human operations. So we're looking for a solution which is high precision, accurate, that we can have minimize the manual operation, standardization, and high accessibility. More important, reduce the time, labor, and skill demand for high quality analysis for both industry and academic applications. So the company we're involved, the bioprocess control, we're based in Sweden. We are actually address this issue by providing a more advanced automate solution to analyze the biomethane potential for feedstock quality check. The company is original spin-off from Lund University, established 2005. So we have headquarters in Lund, Sweden, and we have 15 distributors around the world, including one in India. So we have a lot of quite long experience in instrumentation, automation, and control in biogas and relate about environmental analysis. So our customer worldwide in over 70 different countries in the region, and it's a mature technology business. And what we're doing is we develop smart solution based on patented gas measurement technique. So we're not only, this is the fundamental method, the volumetric method, but based on this method, we further developed into automated solutions and the instrument for addressing what we have what I have just mentioned. For instance, we have the automatic methane potential test system that is a preferred analytical tool for biomethane potential, specific metanogens activity, and also for pre-treatment, co-digestion, evaluation, etc. We have a gas endeavor, which is a new analytical platform for biodegradability and compostability evaluation. Some of them you may know that this is a high interest also in terms of material to replacing the fossil fuel-based plastic. New materials should be biodegradable or bio-based, so the biodegradability could be a very important aspect. So this instrument offers standardized measurement, user-friendly operation, outstanding real-time performance for accuracy and precision. So also at the end, as a result, they lead to more efficient and high quality analysis work, reduce better managing the human resources, and so on. So we have in this event, we have joined the booth with our Indian partner, Ashok Bentek company. So our booth is in number 11. So you are all welcome to look at our product leaflet and it also talked to our Swedish engineer and our Indian partner at our booth. Thank you.
Thank you so much. Thank you, Dr. Liu, for the wonderful presentation. The analytical methods that you discussed hold more and more importance nowadays with the variety of feedstocks that are coming in. And without assessing bioenergy potential or the biogas potential, it's difficult to prove the commercials and the financial viability. So thank you so much for mentioning it.
You're right. Thank you.
So for the last presentation of the day, I would like to invite Mr. Lavraj Khamkar from Technoplast. Dr. Liu, can you switch off your screen sharing?
Yeah, I'll do so.
Thank you.
Yeah.
Yes. So Mr. Khamkar is an experienced business development executive with a history of working in the automotive O&M industry for more than 15 years, skilled in introducing alternate materials for various applications with a strong focus in technicalities of the product and understanding the end customer requirements. He has worked with all reputed Indian OEMs for launching new platforms and working with VAVE to reduce cost to both organizations with meeting technical requirements. He's now heading the Time Technoplast Composites and Automotive Division to launch new innovative products, an engineer by academics with a passion for new development. So Mr. Khamkar, over to you.
Thank you, Siddharth, and thank you, Vishal and Akshat and whole IBA team for your launching this wonderful event, even during this pandemic. And I'll be covering here like type 4 CNG cascades and then increasing profitability of compressed biogas unit with using type 4 cascades. So basically, I'll be covering little brief of our company, and then I'll be covering about what are the different types of cascades and the cylinders which are available in the market, and then I can say comparison of different cascades, and then finally will be the conclusion of how to increase the profitability. So basically, everyone knows like PM or below PM from like India, Mr. Modi already said like we are going in a mode where we should be self-reliant India, and then we should be going for the local for vocal. And Time Technoplast is already in the sync of going in the same direction. And Time Technoplast introduced its most advanced type 4 composite cylinders in line with our respected PM initiative, local for vocal and make in India. This type 4 CNG cylinders are not just based in class or in category, but also available, the best material available in a category and a grade. And now these are made in India for the world. To be like a self-reliant India. And then if you can see most of the competitive can say cylinders like type 3 or type 4 are most of all imported. And we are being proud to say we are the first company in India to launching this cylinders in India. And we are already on a horizon of supplying the cascades, and proud to say like we already have catered a couple of biogas industrial customers which will be using the cascades for this application. Going to little brief of company. This company started in 1992. We are 28 years young company, and company focus more onto technological product, mainly into the polymer category. And this company is like, even though we say Indian company, but I should say we are Indian multinational, as we have operations over 11 countries, including Asia, Middle East, North Africa, and US regions. And this company is focusing more into all new developments and technological product. Not to mention like we have 175 patents, and we have like turnovers in the range of like $500 million US. And company is growing at a rapid pace of more than 18 to 20% on year-on-year. And company is already listed on like stock exchange for more than a decade. And company has very healthy financials and good like profitability. And not to mention like with the profitability, we are also a good competitive edge with the competition. And when any company joins and with Time Technoplast, they have to rest assured with the technology and the support they'll receive with the local engineers and the R&D professionals already working in the company for more than 20 years. This is like a geographical presence of a company. Like we have headquarters in Mumbai and India, and then we have plants all over globe, including Taiwan, Thailand, Vietnam, Malaysia, Indonesia, Bahrain, UAE, Egypt, Saudi Arabia, USA, and many other new locations are coming up, and we'll be launching our additional product into, you can say, new category of composites, which will be covering not more than even CNG composites, but also into like industrial products and automotive segments. So company focus more into like you can say many different verticals, mainly you can say industrial packaging, then you can say infrastructure, maybe you can say pipes, and then material handlings, then auto components and MOX films and composite cylinders. So these are few verticals, even though we have other verticals which are into in category, but I'll be catering more into like a larger categories. And coming back to the composite cylinders, so company is already manufacturing LPG composite cylinders for more than a decade now, and company is already a second largest manufacturer of composite cylinder in the world. And not to mention, like we are already producing almost like 1.4 million cylinders per annum, and we have widest range of cylinders which is available, and it has been used in multiple applications, covering for like boat, forklift, and domestic commercial use. And going a step up from the LPG composite cylinders, companies already produced a Type 4 CNG composite cylinder, which is a most advanced in category, which has composite like a liner, which is like a polymer liner, which is high density, and this is non-permeable liner, so which ensures that there is no permeation of gas from the cylinder. So whatever the gas which is there in the cylinder, which is intact, and it remains in a cylinder for more than like a specified time. And the cylinders are with the PU end caps to have, can say, impact from like a side impact or from a crash impact. And then these cylinders are, you can say, 70% lighter than the Type 1 cylinders. Vis-a-vis, if you compare with the Type 1 cylinders, which goes like around, let's say, around 150 kg, again 150 water liter capacity, the kg of the cylinder will be approximately 140 or 150 kg. In case of composite cylinders, the weight of the cylinder is approximately 45 kg. So it's approximately 70% lighter. And with this light in weight, it increases the fuel efficiency of a system and the vehicle which is carrying it. And then this are like, as this has got the composite liner inside, so it is metal free, and these are corrosion free. So there is no, you can say, rust which happens due to the, you can say, inherent gases or like sulfuric impurities, or let's say with the water impurities which is present in the gas. Even though the gas which we get are more, you can say, sterilized or maybe more clean, but then there are some traces which are present, and then those are causes for the, you can say, corrosion in a cylinder. And with this, as there is no corrosion, so this is like high service life, and then it gives, you can say, maintenance free in the period of complete system. So there is no clogging of pipes, there is no clogging of systems, so the system is completely leak proof, and then there is no issues with respect to maintenance, if at all any. With the manufacturing process, like composite inner liner is manufactured with the high density polymer, and then we have automatic neck fitment arrangement, which is like a patented technology. With this, we ensure there is no leak from the system, and then complete like a liner is fully wrapped with the carbon fiber, which is at high strength, and then it gives a, you can say, strength of more than, you can say, wire. And if you compare the similar with respect to like a carbon strength, which gives these composite cylinders a edge with respect to the Type 1 cylinders or steel cylinders. And then after the fully wrapping the cylinder with the carbon fiber, we have with the curing, which does the, you can say, these carbon fibers are intact in a shape which is we specified test, which is as mandated by PESO, like your drop test, bonfire test, penetration, flaw, cyclic, and leak. But to be on the safer side, we go with the additional test such as impact, cold fast, acid and well strength, and Boss pull out to make sure the cylinders are best in the class, and then these are any worry free, which has been used by any customer. Unique feature of the composite cylinders are basically these are lightweight. So in a vehicle, if you have a cascade which carries more gas than to like in a metal cylinder, and these are highly safe because these cylinders are doesn't corrode, these are doesn't leak, these are non-permeable, and even we have patented bumper technology. And with this, now this cylinders gives with a life of like more than 20 years, and then these are corrosion-free metal cylinders, which is inherent to the gases like sulfur or H2, H2S, or maybe you can say water residues. And these are economical to use as you carry more gas than to any cylinder where you carry actually a still, but not to a gas. And these are like cylinders which is.
We have just 2 more minutes, Mr. Kamkar.
Come again, please.
We have 2 more minutes for your presentation.
Yeah, I'm going too faster.
Yeah.
Yeah. So basically, this again, say metal cylinders are fatigue free, and then one major advantage with the Type 4 cylinders are these are explosion proof. In case of Type 1 cylinder, if at all there is any mishap due to the say gas leak or there is a fire, then Type 1 cylinders are more prone to like explode. But in case of the Type 4 cylinder, these are like fully wrapped with the carbon, so this is like explosion proof. So these are more safe than to any use. This is one representative image of a cascade which is used in our category. And just to give you a little brief of like a type 1, 2, 3, and 4. Like Type 1 cylinders are complete metal. Type 2 cylinders are metal liner with the roof wrap on the periphery. And Type 3 cylinders are the aluminum liner inside, and then outside is completely wrapped with the carbon fiber. And Type 4 cylinders are the polymer liner and then fully wrapped with the carbon fiber. With this, if you compare Type 1, 3, and 4, you can say with the constructions, Type 1 cylinders are much heavier than any category. So if you can consider total weight of a cascade of approximately 9,000 tons or 9,000 water liter capacity, the average weight of a Type 1 cascade goes approximately like 13,000 kg. Vis-a-vis the Type 3 cylinders, weight will be approximately 3,000 kg. And with respect to the Type 4 cylinders, is 2,300 kg only. So if you can see in the comparative, even though Type 3 and Type 4 are the like equivalent technologies, but the Type 4 is like a much way ahead with respect to the lighter in the weight. So these are more than 33% lighter than the Type 3 technology and 70% lighter than the Type 1 technology. If you see the, you can say comparative with respect to the vehicle of use, normally in a cascade which has been used at the 4,500 watt liter capacity of like a 20 feet trailer of like 16-13 truck of Tata. The same capacity, the Type 3 has like 8,970 or approximately 8,800 water liter capacity. With our most advanced technology and with our most unique design, we can go 9,360 water liter capacity, which is approximately more than 500 water liter capacity, more than like with the Type 3, and more than 2 times than of the steel cylinders. If you see with the respect to the corrosion and I can say rusting, Type 1 cylinders are more prone to the corrosion and rusting than Type 3 cylinders are like galvanic, prone to more to galvanic corrosion than to like in the Type 4, there is no galvanic corrosion or there is no corrosion due to the polymer liner which is inside. And rest points already covered. Like if you'll just cover a life of a cylinder, which is like approximately 15 years in a Type 1 cylinder. Type 3 cylinders are mostly used in a 20 years life. And a Type 4 cylinder, if it's maintained in a good way, it can be covering more than 25 to 30 years of life. But in case of the Type 4 cylinders, the additional advantage of like it doesn't require any, you can say, frequent testing. It requires only the visual inspection on regular terms, so which also gives additional savings in terms of the retesting or the recertification. So coming to the, you can say, just I'll go a little brief on to the final savings. Like with Satat scheme, if you see with the any BioEnergy plant, which has had the buyback selling price of 46 rupees per kg, where you can say CBG stations has to give nearby, you can say allotted CNG station. So here, any company which is transporting any gas which has like almost 5 to 10% of the cost which goes with respect to the transportation of the compressed gas. So if you compare with respect to 4,500 liter of water gas to the type of cylinder, your cost of against the CNG carrying capacity is approximately 2.5 rupees per kg to 4.13 rupees per kg. Here we are considering of like around 25 kilometers distance in between the stations, and 4,000 rupees is the transportation cost here, and gas can be transported of around like let's say 967 kg in terms of 4,400 liter water liter capacity. If you will compare with the type 4 cascades, the transportation cost will be approximately coming drastically down to like 1.19 or let's say 1.2 rupees to let's say 2 rupees per kg. There is a tremendous saving of almost 50% in terms of the transportation cost. If you say in a unit which is carrying let's say around 5,000 kg of gas in a per day basis, so they can have a daily savings of approximately 10,000 rupees per day. And if you calculate that into 25 days in the working days, then it goes like a monthly saving of like, let's say 2.6 lakhs per month, and yearly savings of amounting like 32 lakhs. If you calculate like a life of like a project of around, let's say 20 years, but normally in a CBG plant, which is an operation which goes more than 30 years, but even though I'm like taking as a decent life of like, let's say 20 years. So with this, any entity which is using type 4 cascades, which can have a saving amounting more than like let's say around 2.95 CR or let's say 5 CR in a total lifespan of like 20 years. And here I'm reducing the capital cost involved at approximately like let's say 1.5 CR for the 2 cascades, which is required for carrying around let's say 5,000 kg of daily output. That's it from our end. Thank you. Thank you, Siddharth. Thank you for IBA for providing this opportunity and sharing our viewpoint.
Thank you, Mr. Kant. A wonderful presentation. In fact, the safe and affordable storage and transport of biogas and bio-CNG is of importance for development of this sector further. So thank you for the information. So with that, we have concluded presentations lined up for today. Once again, thank all the presenters for the wonderful insights they shared. We'd like to be taking some questions right now. Can I request all the presenters to switch on their cameras if possible? Can you switch off your screen share?
Yeah, that's what I'm doing actually.
Okay. Yeah, okay. So we have received certain questions from the viewers. So I'll go sequentially. So for Mr. Hartel, the first question, does revenues from selling the undigested slurry as fertilizer factored in modeling the biogas projects in Germany? And also how mature is the market for upgrading bioslurry in Germany?
I didn't understand it correctly. Is it possible to send the questions?
We will certainly do that. So if I understand it correctly, the question the viewer is asking is the undigested slurry, whatever is remaining, is the revenue from selling that factored in the models that you have prepared for biogas projects in Germany?
About slurry?
Yes. So the undigested slurry, so
I have some problems to understand it acoustically because there are always some.
I'll ask IBA team to question and ask the viewer in detail if possible. The second part of the question was how mature is the market for upgraded bioslurry? Is it a market driven? Is the bioslurry sold on the open market in Germany right now, the digestate, or it's?
I'm very sorry because it's interrupted. The
Mr. Hartel, I just dropped it in your chat box, so please check your chat box. The question is
okay, thank you. The upgraded bioslurry. Maybe this could be also a market, yes.
So the market, so in Germany, you have an open market for selling bioslurry. Is that, I think that is what the viewer is asking.
I think, yeah, the market in Germany, we have to establish the market. So we have different goals and aims in the project. It depends on the location of the plant and the size of the plant. So it's not easy to answer it generally. So we have to look to the individual case assessment. So yes, we have a market, but we have to establish it.
Okay.
But
okay.
we have also the problem with the nutrients on the field.
Okay. Okay. Thank you. The next question I'll ask Mr. Basavaraj. The question being asked is, how are the challenges, or what are the challenges setting up a biogas project, different from setting up projects in other industries, specifically biogas compared to industries? And of all the bottlenecks, which are the main bottlenecks that stand out in setting up biogas projects? Sorry, can you unmute, Raj? You're on mute.
Oh, sorry. So if I understand your question correctly, one is what are the challenges in setting up the biogas plants, and what are the bottlenecks for this project? So is that right?
The most intense or hurting bottleneck, if you were to evaluate one.
Yeah. So basically, the bottleneck is, I mean, two. One is the assured raw material and the assured offtake of the CBG projects. So these are the two bottlenecks which I feel. So rest the intensity would be less, but there are other bottlenecks.
Okay. One question is there for Mr. Maheshwari. Are there instances of any plant with originally a different upgradation technology and then later substituted with membranes? Cases, what kind of payback or cost benefit figures are we looking at?
There are various references. I can say that is in Europe. Those were with other technology and then replaced with the membrane, Sepuran green technology. In general, based on the application and the capacity size, the payback can be around 3 to 4 years over the time with Sepuran green.
Okay. And what about the moisture, nitrogen, and oxygen? Can the membranes handle that?
Actually, the pre-treatment part is needed, as mentioned earlier. Like H2S, it is not the harmful to the membrane, but it will pass along with carbon dioxide. So it will go with CO2. So better to remove that to get the CBG specification also. So similar way is the moisture. When we getting the methane, it's completely dry and at the system pressure. So it will not pass through the along with methane. So membrane is much more chemically stable and thermally stable against all because of its polyimide properties.
Okay, thank you. The next question is for Dr. Liu.
Yeah.
Is it possible to do a BMP for all traits, even the lignocellulosic ones? And for such feedstocks, the pre-treatment is bound to have an gas yield, yes or no? And during the lab scale, how do you ensure that the on-field scenario is replicated? I mean, how do you scale up? Essentially, how do you ensure the scale up?
Yeah.
Of this analysis?
Okay. So in general, put this way, and for BMP analysis, you can basically apply to any feedstock with and without pretreatment. And actually, this is the way to evaluate whether the pretreatment can improve the biodegradability and enhance the gas production, yes or not. And in what type of pretreatment? If you're talking about lignocellulose, for instance, you may using the soap enzyme, you may using different way, skin explosion or something like that. There are different ways to pretreat. I mean, there are many, but how efficient and how intensity that can be carried out. This is actually to using the batch fermentation test, similar to BMP, is the best way to evaluate. In terms of scaled up, the batch test only tell you the fuel of your biogas plant, because the feedstock is the fuel for biogas plant. But to the efficiency, whether it can produce efficiently in large scale, and not only depending on the fuel, but also depending on how you operate your plant. Therefore, you need to get a good understanding of there's a good ecosystem need to be in the biogas digester, the certain operation parameter, retention time, temperature, all these things has to be evaluated. But that will come with operational experience, and you can certainly optimize that through the continuous fermentation test. So in my presentation, I mentioned the batch test, I mentioned the continuous test. Batch test is for the feedstock, or you can say the fuel for biogas plant. Continuous test is to how you optimize, how you steering your biogas process towards to maximize the production. So I hope I answered the questions.
Thank you so much. Thank you. For Mr. Kamkar, one specific question about what when the cylinders are involved in any collisions during transportation? What about the cylinders if there is a fire around it?
Yeah, that's the point I covered even in my presentation. So our cylinders are already with like a side end caps, which is protecting it against any, you can say, collision or any impact. So even though cylinders are, you can say, equivalent to the strength of like a steel cylinder, but even though if there is a major crash where even the, you can say, even the metal also get collapsed or metal also get crashed. So during that time, the gases will, you can say, move out from the cylinder. It will not, like in case of the steel cylinder, if you crush it, it will open up, or it will open up in a complete way. In case of the, you can say, composite cylinder, it will inert the gas in a slow manner. So if during the, you can say, heat, when it's been given, the polymer liner will, you can say, slowly, you can say, start picking up the heat, and it will try to melt. And whatever the gases which will come out, it will come out very slowly from the cylinder. It will not have any, you can say, explosion like you can see in the Type 1 cylinders. So you must have seen some videos, if you go on YouTube or something, you see the vehicles get explode. The CNG cylinder, CNG tanks get, you can say, fire to it. In case of the Type 4 cylinders, the major advantage with the Type 4 is it doesn't explode. Whatever the gases will be there, that will go very slowly out. So it will permeate slow gases, which will to the environment, and then it will go very slow phase manner fire. That's it.
Great. So thank you so much. We are out of time, so unfortunately we have to stop here. Once again, I'd like to thank all the presenters and IBA and the organizers. I think this particular session, we covered all the relevant, touching all the aspects of, I guess, including the biogas potential, which Dr. Chin, how to assess the potential, then the biogas generation and the PFR tech, which Mr. Basaraj from Raj mentioned. Then the separation part, which Evonik is doing wonderfully. Mr. Maheshwari mentioned that. The storage and transport, which Time Technoplast and Mr. Kamkar mentioned that. And finally, the digestate fertilizer, how digestate can be fertilizer, which Dr. Hartl from German Biogas Association mentioned so nicely. So once again, thank you for your time and the wonderful insights you shared with us today. Thank you so much.
Thank you.
Vishal?
Thank you.
Thank you.
Yeah, thank you, sir. Thanks, everyone.
Thank you.
Thank you.
Bye.
All done, Vishal?
Yes, sir.
Okay, thank you.
Yeah, thank you, sir.